Write down the numerical now. Yesterday we learned one numerical. We write down the next one. A copper wire. Write down. In the last session we have learned, we have written this. Let me read it once again. A copper wire of length 2.2 meter and you have written this. We continue with that. A steel wire of length 1.6 meter, both of diameter 3 millimeter. Okay, just continue with that. The last bit to be written are connected to end to end. When stretched by the load, the net elongation is found to be 0.70 millimeter. Continue that. If most probably we stopped there. Net elongation is found to be 0.70 millimeter. Obtain the load applied. If you have written that, we start writing the things. So we know Young's modulus formula. Let me write. Young's modulus is F by A divided by delta L by L. We have to use this formula. There are two wires now. Length of copper wire, I will tell you later on. Just look into the problem. F by A delta L by L. Here we wanted the load to be calculated. The load is F there. F is the load, applied load. Therefore, we can simply write like this, F L by A delta L. So simplifying it, F equals Y A delta L by L. This is the formula for load. But observe, using this we can write the load formula for both the things as same load is applied. So we write for copper and brass, say it is given like this. Say, we read the problem once again. A copper wire of length 2.2 meter and steel wire. Say, the figure is like this. This is the copper wire and this is the steel wire. Two wires are connected end to end according to the figure what they have given. And the net elongation is found to be, net elongation means once you apply a load there, F, both of the thing added together will give you the elongation delta L. We call it is 0.70 millimeter given, 0.70 millimeter given. And then length of copper wire, if you take this as copper, we write all the data here. LC 2 meters. Sorry, 2.2 meter. And length of steel wire is 1.6 meter. I call it as LS. S stands for steel. 1.6 meter. Obtain the, and both of the things are diameters, same diameter. Say this diameter is same for both, which is 3 millimeter. So this is the data given there. And obtain the load applied. You are asked to calculate the F. For that, say, you can use this formula for any one of them, for copper or say steel. But before that, observe, we don't know delta L separately for copper or steel. We know total elongation. Total elongation means delta L equals delta LC plus delta LS. That is elongation for copper, elongation for steel. Both to be added to get delta L 0.7 millimeter. So with these things now, they have to give you Young's modulus also. It is given, in fact, not in the problem, in the solution, but you are supposed to write down this. Young's modulus of copper, I write down. Young's modulus of copper to be given, otherwise we cannot solve. Young's modulus of copper is 1.1, 10 raised to 11 Newton per meter square. Young's modulus of steel, yesterday we have written structural steel 2.0 we have written here. Here also it is 2.0, 10 raised to 11. Both of them are 10 raised to 11 power minus 2. So now how to solve this problem? Can you think of? Say from this, you can write it for copper or you can write it for steel. Both of them, same formula, only the terms are different. Say you know the copper, YC, the Young's modulus, or steel. Area, we can calculate, diameter is there for both. L, we know length, but for copper, delta LC is not known. For steel also, delta LS is not known. So whole crux of the problem is to find delta LC or delta LS. Once we find that, we can straight away simplify to get load. So how to calculate that? How to calculate delta LC, delta LS? Can we think of? Same load is applied. So how to think of? For that, I write this for both the things, copper, and I equate them because load is same for IYC, AC. AC is same as AD, AS. So let me write only single here. Delta LC by LC should be equal to YSA delta LS by LS. LS. Now here you can cancel A because diameter remains same. We cancel A there. You know YC, you know YS, LC, LS known. You can calculate delta LS by delta LC, so you can simplify. First write down this much, then we can proceed with the other calculation. Write down these things carefully. This we can write delta LC by delta LS as delta LC. It is YC here, YS here, into LC. LC should go to numerator and LS. This is the formula for delta LC by delta LS. And using this, we can calculate delta LC separately, delta LS separately, using this total. Do this quickly. Substituting everything, you complete the things. Say we write that. We substitute everything. YS 1.1 only I write. YS 2.0 only I write. 10 raised to 11 cancels. 1.1. If you want, you can write one step. Nothing to worry. What is LC? LC is 2.2. This is 1.6. Simplify this. How much you get? You just get me. 10 raised to 11 goes there. 11 2s are. And 2 2s are 4. 4 by 1.6. How much it is? 4 by 1.6 is 1. We can think of like this. 1 by 0.4. 1 by 0.4. 4 ones are 4. 4.4s are 16. 1.6. 0.4. That is 10 by 4 for that matter. It is 2.5. 2.5. Is that right? 2.5. Delta LC by delta LS ratio is 2.5. You substitute this for this and you get any one of them. That is sufficient. I'll just rub off this. I'll go for the calculation now. Say we know delta L equals delta LC plus delta LS. But from this expression, I can write delta LC as 2.5 delta LS. Substitute that for this equation. 7 millimeters, so 7 into 10, 0.7 millimeters, 10 raised to minus 3 there. Delta LC, I keep it as it is. Plus for delta L, I write 3.5. Delta LS, wait. So sorry. Delta LC, I have to substitute. This is delta LC by delta LS. So delta LC can be written as 2.5 delta LS as we have written. Delta LS plus delta LS. Go for the calculation. 3.5 delta LS is 0.7, 10 raised to minus 3. So delta LS is 0.7, 10 raised to minus 3 by 3.5, which is also easier calculation because 7 5s are 35. So 1 by 5 into 10 raised to minus 3. So 0.2 millimeters or 0.2, say 10 raised to minus 3 meter. That is the answer for delta LS. You need not find delta LC because that's not required. You can apply it to one formula and you'll get the load. Remember, applied load remains same. Stress and strain are all different inside, depending on their, say, Young's modulus and all those things. Applied load is same. That applied load is taken as F. So delta LS you got. Finally, we go for the last calculation. I rub off this figure now as you have written. We substitute for any one of them. What is the formula which we have written there? F by A Y delta L by L, or else F equals YA delta L by L. So substitute everything there. We go for steel only. Steel is 2.2, 10 raised to 11. Delta LS is 0.2 millimeters, means 0.2, 10 raised to minus 3. Area pi or say diameter is given. Diameter is, I write down on this side. Say diameter we know 3 millimeter. You can use diameter for area calculation, pi d square by 4 formula. Or radius means 3 by 2 millimeter. So then pi r square is the formula. We substitute everything there. So r is 3 by 2. 2.2, 10 raised to 11. 0.2, 10 raised to minus 3. Pi 3.14. R is 3 by 2, 10 raised to minus 3 whole square. You simplify this, you will get the final answer. Write down and simplify it. This goes there. 0.1 times. So what is the calculation required? So instead of doing it because power is there, so we'll do it later on, nothing to worry. 2.2, 3.14 into 9 by 4, 3 square by 2 square, 9 by 4. What are the powers there? 11, 10 raised to minus 3, 10 raised to minus 6. Go for all the calculations there. We have written every power there. So you have to be careful regarding the powers. 3.14, 9 by 4. Total power is 6 minus 6 plus 3, 9. 9, that is 10 raised to 2 is there. Load, power 10 raised to 2. Get me the final answer for this. Get me the load calculation. Steel, we are substituting. What is the steel wire length? We have left the length, sorry, there. What is the steel wire length? This to be divided by length. Steel wire length is 1.6. That's what we have to substitute. Length of the wire is left there in the denominator. I am substituting it into 1.6 there. Go for the calculation. Length of the wire I have left. Go for the calculation. Final calculation. You must get 1.8 10 raised to 2. Power we already have. Only the number. It should be approximately 1.8 10 raised to 2 you must get. What is the unit? Newton. Newton is the unit. I left there denominator L. L means for steel I have to substitute because I have taken for steel. So what I am substituting is YS delta LS LS. So I hope all of you got it. You finish up it and we want to solve one more numerical. We proceed on to next problem. Write down. This problem is very beautiful problem. It will tell you how the nature provided us bones which are how much stronger. We will learn from this. We go for it now. In a human pyramid, write down. In a human pyramid, what is that? I will tell you later on. In a human pyramid, in a circus, the entire weight of the balanced group is supported by the legs of the performer, who is lying on his back, say it's given in the figure, lying on his back, as shown in figure. We write a rough sketch there. As shown in figure, you write down. The combined mass of, next sentence, the combined mass of all the persons performing the act, and the tables, plaques means sheets, wooden sheets, plaques, 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 etc. involved, is 280 kg, 280 kg, full stop. The mass of the performer, lying on his back, at the bottom of the pyramid, is 60 kg, 60 kg. Is 60 kg. Each thigh bone, what is the name for thigh bone? Another name for thigh bone? Can somebody get me? Each thigh bone, femur. Within the bracket you can write F-E-M-U-R. Ganesha Gaur, right? Femur, F-E-M-U-R, not M-O-R. M-U-R, femur, close the bracket. Of this performer, has a length of 50 centimeter, and an effective radius of 2.0 centimeter, determine the amount by which each thigh bone gets compressed under the extra load. Say, most probably you have seen this type of things in circus, if you have seen it. Say, I write down a rough sketch. What is the problem? Actually, problem figure is a person is lying on his back like this, lifting his leg and supporting the wooden planks there. On this, two more personnel are standing. I'm writing rough sketch. They are having a plank overhead. Then It goes on happening like this, stretching on top like this. It goes on. This is what we call as human pyramid, and later on it comes to the top peak value. Here, what they are asking us to calculate is, it is to be taken as exactly 90 degree, we take it like this. Say this person who is lying on his back on at the bottom, his thigh bone, how much it gets compressed, each leg thigh bone, is the thing asked. That means we are asked to calculate delta L, change in length for that. How to do that? Here, one thing is to be given, write down. The Young's modulus of bone is given, write down. Young's modulus of bone, Young's modulus of bone, Young's modulus of bone is given, y equals 9.4, y is 9.4, 10 raised to 9, 9.4, 10 raised to 9 Newton per meter square. That is the Young's modulus of bone. Now, how to solve this problem? First of all, we have to find what is the force load applied on his legs. So, we are given with total weight 2 kg, 280 kg, all these Planck's personnel, including this performer. Overall, the team weight is 280 kg. But this performer who is lying on his back to be subtracted because his weight is not going to support there. Therefore, net weight supported by performer, by bottom performer, I say. Bottom performer is equal to 280 minus his weight, 60. That is 220 kg. Because he is not supporting his weight. His backbone is supporting. We wanted his legs, load on the legs. That's why let's remove the weight of the performer lying on his back. That is at the bottom. 220 kg weight is supported. But observe, two legs are supporting that 220 kg. So what is the one leg support? What is the weight on one leg? 110 kg, half of that. Therefore, weight supported by each leg is, we call it as W, 220 by 2, it is 110 kg. Weight supported by one leg of the performer is 110 kg. So now we know WRF, applied load. And area you are given, the bone diameter is given, approximate average diameter, how much it is given? How much? What is the average diameter given? 2, let me read it. 2.0. The effective radius is given 2.0. Effective radius of the bone is 2.0 millimeter, 2.0 centimeter. Okay. That is the radius. Why it is given average? Because shape of the bone is average radius 2.0. And length is also given. What is the length of the femur? 50 centimeter, half a meter. That means I take L 50 centimeter. We convert it into meters there itself. 2 into 10 raised to minus 2 meter. 50 into 10 raised to minus 2 meter. Like that. Once you know Y, L, R, Y, all those things, you can straight away calculate the compression. What is the formula for compression? We write Y equals F by A, L by delta L. Substitute everything, you will get the answer. What you want is the delta L, Y, A, say, I have to write F, L by AY is delta L. Substitute everything, you will get. What is the load now? 110 kg. L, femur length is 50, 10 raised to minus 2. And A, area, pi r square. pi r square into Young's modulus 9.4 10 raised to 9. You substitute everything and you will get the final answer. So we're left with 10 more minutes. We continue with these things. Go for it. Go for the complete calculation. Write down and complete the calculation. You'll get 4.55 10 raised to. Go for that. Ten raised to minus 5 meters. So that gives you an astonishing result. What is that astonishing? We'll think of now as the last bit for this session. So that is delta L. If you have written this, I write it on this. Delta L is 4.55 10 raised to minus 5 meter. Or if you write it in millimeter, 4.5 10 raised to minus 2 millimeter. That is 0.0455 millimeters. How much smaller it is? Observe. What is the compression there? It is observing. I hope all of you have written this. First, 0.0455 millimeter. How much smaller it is? You can make it 0.05 only, nothing to worry. According to the idea of, say, rounding off, we must keep it as 0.04 only. No, because if you want to end at this point, you have to look into the previous digit, which is even or odd, if you can remember what we said in the earlier classes. So if it is even, you have to drop that and keep it as it is without adding 1 to that. So now it is 0.04 only. Okay, we'll take it as 0.05 millimeter. How much it is? Say that thigh bone of that person, if it is 50 centimeter there, with that so much of load, it gets compressed by 0.05 millimeter. Means what? Say in your scale, one small division is 1 millimeter. This is 5 by 100, as we have written here. Millimeter. That means you make this one small millimeter into 100 divisions. Out of that, you take only 5. So you can feel how much smaller it is. You will not be able to get it. Very, very small. That is the nature given gift for us. Our bones are very, very strong to withstand so much of weight of 110 kg. Even then it gets compressed only by very, very small amount. Therefore, we have to keep them healthy till our age. Giving it a good exercise and taking the good food as far as possible. And very important is not taking the food, but doing the exercise also. So that's what is important. And by this problem, we learned how stronger our bones are. So with these things now, we are coming to the end of this topic.